You know, when you think about it, most of the problems we face with energy security and pollution stem from our attempts to heat water in a way that both maximizes profits and remains marginally safe enough for government agencies to approve them. Most of the ways that we create electricity involves the conceptually simple but technically dangerous task of boiling water to create steam to drive a turbine that spins a dynamo in a generator. Electric power stations are basically giant tea kettles that either use the heat coming from the fission reaction of deadly radioactive materials to boil water, or ancient lumps of carbonized wood that release their own radiation as well as arsenic and a surfeit of CO2 into the atmosphere when burned, or ancient toxic liquid hydrocarbon goop, usually from politically unstable regions, or gases released using chemical processes that poison our water supply. But does heating water need to be so problematic? And do we need it to create electricity? Obviously no. We have technology to turn dynamos directly using wind and cold water from streams and rivers and waves and tides, and the combustion of biofuels and internal combustion engines and geothermal heat. We have materials that turn light photons directly into electrons and electric current. So of course we can create electricity without heating any water at all. And if we want to heat water, we can create hot water without using any fossil fuels or radioactive rocks at all. Do we need electricity to heat water? Obviously no. We can heat water with efficient on-demand heaters that burn biofuels directly, or we can combust biofuels in combustion engines coupled to CHP, combined heat and power heat exchangers, and actually get both electricity and hot water from the same process simply by capturing the waste heat that engines give off. Technically, these are all simple and are being done all over the world at various scales. But of course, politics and profit get in the way, and any move away from coal, oil, gas, and nuclear power, especially when talking about large-scale processes that are controlled by large-scale capital investors with huge political clout, it's a problem. We normal citizens don't have a lot to say in that domain unless we can prove there's a better way. And the problem I see is that most of the people we call consumers don't know enough about the alternatives to make strong demands or strong consumer choices. So forgetting about industry for a moment, what can we do as citizens to get out of hot water when it comes to hot water? What can we do at home to prove to ourselves that there's a better way and to live it every day? To answer that question for myself, I turned to the poorest section of one of the trouble spots in the world to see how people who have no power, political or technical, get along. I chose to live in a community where the electric power and the water were always being cut, where I would have to figure out how to get hot water without getting into hot water, politically, financially. Studying hot water provision in the slums of Cairo, I became interested in the issues of hot water demand and provision in and around Old Cairo in the spring of 2006, when my thesis advisor, Randall Crane, and some 25 graduate students from our urban planning program at UCLA came to visit on a field research trip, and we took them to the historic Cairo slum community of Darb al-Ahmar and the informal garbage recycling community of the Zabaleen, or garbage pickers, in Manshiat Nasser. Having recently built and installed our own solar hot water system on the roof of an unfurnished apartment that my ex-wife and I had rented in the desert development of Beverly Hills, Egypt, I became curious how the urban poor were dealing with their own hot water needs. In our case, living in a new model community with limited funding, we were concerned that the layout of our apartment immediately determined the choices we were to make as consumers. Each of the 3 bathrooms and the kitchen were plumbed and wired with the expectation that the renter would install a separate electric water heating appliance into each room. The pipes to each room were separate circuits, meaning that a heater installed in the kitchen could not provide hot water to any of the bathrooms or vice versa. To have hot water in each room would have meant purchasing 4 separate heaters. Now, at an average price of 500 Egyptian pounds for each small 50-liter heater, we would have spent 2,000 Egyptian pounds, which is just 500 Egyptian pounds less than the average materials cost for the kind of 2-panel, 200-liter solar hot water heater manufactured by the Wadi Foods Company, whose educational initiative, the Wadi Environmental Science Center, I was helping design. My now ex-wife and I chose instead to convince the landlords of our apartment to allow us to install the solar hot water system on the empty roof and run temporary pipes 4 stories down the air shafts to the bathrooms. It wasn't an easy job, but the learning experience was worth it. It forced consideration of how the built environment biases and constrains consumer choice. The question then became, what constraints are there on consumer durable choices in the 2 communities we visited on our UCLA research trip? In both areas, after presentations by community representatives talking about development initiatives, I asked whether any work was being done on overcoming barriers to alternative energy solutions and other clean development and inflation-resistant environmental technologies. My question was prompted by a paragraph in a 2002 paper in the European Journal of Political Economy that stated, quote, "The question becomes urgent why not everybody is employing best practice technologies, even though these technologies are known and yield, by standard means of calculation, a positive net present value. In, for example, the field of environmental economics, much attention has been paid to the seemingly paradoxical evidence that firms do not employ those environmentally friendly technologies that, according to standard calculations, yield positive net present values. This paradox is often referred to as the energy efficiency paradox and has given rise to an extensive literature trying to resolve it. See, for example, Howarth and Anderson of 1993, Jaffe and Stavins, 1994, and Sutherland, 1991. The question that began to gnaw at me was, what is a best practice technology for the diverse problem sets that we find in a planet of slums, to quote Mike Davis? Who determines what constitutes an advantage in areas where all costs are high, from materials costs to information costs, relative to the average income of the population? How do the urban poor perceive the trade-offs they must make and the opportunity costs they face when considering how to, or even whether to, heat their water? And if solar domestic hot water could be proven to be economically superior to all other options, what might be impeding its widespread use? How do we investigate barriers to implementation? And how might we use our findings to change policy? For example, government support for businesses and energy efficiency, such as low custom rates on efficient devices, equity loans, tax incentives, etc. You can see CHEDID 2000 for that. And how do we do it so that we can help everyone employ best practice strategies? Dr. Salah Al-Hagar, AUC's engineering professor, whose nameplate is still on the defunct rooftop solar energy lab there, was quoted in an English-speaking Egyptian newspaper as saying that urban Cairo had implementation problems for domestic solar hot water, in large part because of its density and the sheer dimensions of its high-rise buildings. He felt that in general there wasn't enough roof space to provide for every apartment and family in the building, but that argument doesn't explain why solar hot water isn't found in historic Cairo or in its informal areas where the built environment is mainly low-rise buildings that offer plenty of roof space. When I asked Dr. Al-Hagar personally, inquiring also why he no longer took an interest in solar energy and had abandoned the lab, he referred me to a bookshelf in his office filled with texts on solar energy, sustainable development, and economics, and he said, "We did all this work in the 1970s and 80s. We proved it was feasible, beneficial, and advantageous from an engineering standpoint, from an economic standpoint, and from a social and environmental standpoint. But the politicians didn't want it. We couldn't get widespread support. I'm fed up with the whole thing. It's up to younger people like you to fight this fight now." Well, now with climate change, clean development mechanisms, and the possibility of carbon trading, and Egypt's need to carefully remove its energy subsidies so that it can export its gas and oil for hard currency without creating the kind of riots it recently experienced when food prices went up, a reconsideration of the country's renewable resources is taking place. But even with a plethora of new studies, Cardinal in 2003, Chedid 2000, Langness and Inca, Sideris 2003-2004, Langness 2008, McGonigal 2005, and there's been more recent literature, even with these studies providing the numbers and showing the enormous potential of solar technology to address Cairo's development challenges and help its economy in the world market, there's still an enormous amount of work to be done to understand the true value of hot water to the urban poor, and what and how much government, the market, and NGOs have to do to guarantee safe, reliable, and economic access to this amenity. While much work has been done exploring the energy paradox at the level of the firm, and some work has been done in modernized countries at the level of consumer choice. Very little has been done at the level of the household in developing countries. Typically, a lot of effort has gone into finding ways to provide renewable energy systems, solar, biogas, wind, for the rural poor. See, for example, the Stockholm Challenge and the GEF small grants programs. And this is because those who live in remote off-the-grid locations are in a situation where the immediate economics of decentralized energy are favored by the ability to offset the cost of running services to the village. The urban poor, by contrast, have often been neglected as the target of clean development initiatives, presumably because they already have access to city services such as water, electricity, and gas. It has been felt that the economics of scale, the economies of scale, already reached in urban agglomerations obviate any advantage to be derived from retrofitting existing structures or exploring new ways of creating the built environment. And while McGonigal 2005 has dealt with the theoretical problem of accounting for solar's cost in an urban setting, changing its accounting mechanism from payback, which is typically 7 to 10 years, which reduces potential market penetration to less than 5% of consumers, to life cycle costing, the utility industry standard practice through which solar technologies emerge as the best least cost option, it is hard to get quick market penetration when other barriers persist: upfront cost, low awareness, lack of codes and standards, lack of skilled installers, no legal right to light. No legal right to light. And the fact that heating issues, quote, do not have a high-tech image amongst consumers and policymakers, and little is known about the demand side of the consumer market in urban poor areas. On the other hand, in slum upgrading and in informal housing situations, the possibility does exist to make major infrastructural changes, particularly at the household level, because international development agencies, quote, often led by the World Bank, have been at the forefront of promoting slum upgrading programs, end quote. And the premise of many government policies was that housing conditions might appear substandard, but are likely to improve over time. Mujica 2000, page 13. Tenure legalization was considered key to improvements, with the assumption that people with legal title to their holdings would be willing to invest in upgrades and improvements. A necessary marriage must be made, they say, between the slum and the informal dweller's demands in terms of real utility, and the palette of upgrades and improvements on the supply side. In our visits to the two communities around Old Cairo with the UCLA Urban Planning Group, I found myself wondering which of the areas was more likely to embrace and adopt changing technologies, and what it would take to kickstart a renewable energy revolution in Cairo. Our hosts replied that one of the reasons environmentally friendly technologies were not being considered in the area was simply that, they said, you are not here to put it on the agenda. Each of us working in development, they said, has an interest and a passion, and there are few of us, and our time and energy are limited. So if you believe that renewable energy can make a difference here and want to dedicate yourself to finding ways to make it work, you are welcome. Tfaddal. You are welcome to come and join us. When I decided to follow up and met with Izzat Naim Gundi, the Zabaleen representative we'd met in his office at the German Agency for Technical Cooperation, he provided me with a research report they had done that showed that in the area we had visited, up to 3/4 of the residents surveyed reported having no hot water. Foreigners told us that this was nothing to worry about because Egypt was a hot country. This argument made sense during the summer. But my ex-wife and I had been living in Egypt for 3 years, and we knew how uncomfortably cold the winters became, and we'd lived literally without hot water service for a month while we were building and installing our solar hot water system in our unfurnished apartment in Beverly Hills, Egypt. We had resorted to boiling water on the stove and in an electric tea kettle to prepare our bath water. We also found that we needed hot water in the summertime because mornings and evenings could still be uncomfortably chilly inside. Why would Cairo's poor behave any differently from us? Were they simply hardier than we were, used to putting up with discomfort and willing to bathe in cold water? I was familiar with this in tropical Indonesia, where we were forced to take a cold mandi every morning. Many days I resorted to waiting until 11 a.m. to heat water in the sun in a black plastic solar shower bag, to the amusement of my native hosts. Or were they meeting their hot water needs adequately using materials other than appliance heaters? Perhaps the GTZ data, by equating appliances with services, were misrepresenting the on-the-ground reality. Perhaps the report was conflating modern dedicated water heating consumer durables with hot water itself. A possible explanation was that everybody actually had hot water, but that they were getting it using capital stock they already had, and didn't find it cost-effective to invest in more convenient hot water appliances that actually led to greater sacrifices in convenience and financial security. As Houseman stated in the classic paper from 1979, if an econometric model of energy demand is to be successful, it must allow for the different nature of the adjustment of the two components of household energy demand. Econometric models which do not differentiate the capital stock decision from the utilization decision cannot capture the interplay of technological change and consumer choice in determining final energy demand. Engineering models which do not allow for consumer choice but instead assume that the least cost design is adopted will fail to capture the diversity of consumer behavior. End quote, page 34. The energy paradox literature isn't the only one to offer solutions to the Cairo case. Houseman's caution that we use models that differentiate stock from utilization and try to capture the interplay of technological change and consumer choice also includes the caveat that we not make assumptions about what least cost design really means, and to whom. Newell, Jaffe, and Stavins in 1999 reminded us that, quote, technological change is inherently a microeconomic phenomenon, end quote. While Kant and Groot and Nahuis, 2002, in the European Journal of Political Economy, have tried to get us to think about the impact on different social classes, not just on owners and managers of firms or businesses. The basic conclusion we arrive at is that new technologies that carry a substantial cost that is necessarily borne by workers are unlikely to be adopted. Moreover, in an anti-competitive environment, it is more likely that a new technology is resisted as the share of the rent associated with the new technology that accrues to workers is relatively small, making them more hesitant towards adoption. End quote, page 4. Their logic could also be applied to households. The cost of many technologies may be differently borne by different members of the household. Many times in our survey, we visited households where a bathroom had been created with pretty ceramic tiles and an installed electric heater as a way of attracting a wife, the bowerbird phenomenon. But shortly after the marriage, the heater had been disconnected and the wife asked to return to heating water on the kitchen stove. In other households, people who had had bad experience with appliance heaters had adopted what was to them a newer technology, which we in the West consider a step backwards, the one-eye portable gas stove. See, small portable gas stoves are easy to move around the house, much easier than the traditional kerosene babur, but they emit no smoke and are inexpensive to fill, and they began to hit the Cairo market a few years ago. Previously, the only gas canisters available were the large tanks used for kitchen stoves. The small portable one-eyes, known in the West as butane camping stoves, are made in China and can be purchased for as little as 50 Egyptian pounds in nearly every small shop in both communities, making it by far the easiest way to heat water. They put out roughly 16,500 BTUs and they take approximately 3.5 minutes to boil 1 liter of water. Thus, 10 liters of bath temperature water at 40 degrees Celsius can be heated in approximately 15 minutes. From the perspective of many end users, these stoves carry advantages that conventional appliances do not. It takes the same amount of time, for example, to heat water with an electric heater. And because of their newness, they're actually considered modern and therefore desirable. The energy ladder literature explores some of the biases we bring with us when we assume that development follows a linear technological path from heavier to lighter fuel sources. The literature assumes that, unless otherwise constrained, people will progress from solid fuels to liquid fuels to gaseous fuels, and finally strive for the apogee of light fuels, electricity. The literature is curiously silent about the lightest of fuels, light, and makes almost no mention of solar energy as a part of the putative ladder. Isn't that interesting? A lot of marketing effort by oligopolists like Olympic Heaters, Olympic Appliances, an Egyptian manufacturer which has 85% of the market share in white goods in Egypt, has been put into convincing Egyptians that electric heaters are the most desirable, the apogee of civilization. From the perspective of many bourgeois Egyptians we talked to, going back to gas was considered retrograde motion, and using a camping stove, using one indoors, a form of barbarism. Even solar heating was considered by a radio show host who interviewed us to be something that would only be appropriate for and interest the poor. The host said, "I admire what you do, but in Zamalek we like our electric heaters." Nonetheless, the advent and abundance of efficient low-cost camping stoves in a market where nobody has the luxury of camping shows that families are considering these stoves to be technological advances. A good source for these arguments is Barnes, Brendan R., 2005, in Interventions to Reduce Child Exposure to Indoor Air Pollution in Developing Countries, Behavioral Opportunities and Research Needs in Children, Youth and Environments, Issue 15, Volume 1, 67 through 82. Go read it. But why had efforts to induce solar hot water since the 1970s failed? And why was there data suggesting that up to 3/4 of some of the neighborhoods had no hot water? Two possible explanations are those that were given to us by bourgeois Egyptian employees of USAID when we applied for a grant to train people how to build solar hot water heaters for themselves. One, the poor don't need hot water. And two, the poor aren't well enough educated to understand new technologies. I lived with the poor. I'm of Arab ancestry. I consider these bourgeois sentiments to be offensive. Other, less prejudiced, and more likely possibilities are that the city's poor communities are caught between infrastructural constraints, information asymmetries, and cultural norms that compound the difficulties they face in making rational choices, while at the same time, uncertainties about the government-subsidized energy prices distort market incentives to pick the optimum watergy solution for their income. This is particularly true when there's no sub-metering. See Lampieri et al. 2001, Utility Pricing in the Poor for more on this. In my view, it was possible to test all these possibilities using the optic of consumer choice theory, which assumes rational actors satisficing based on the information and opportunities around them. But what is it about these two communities that makes their aggregate choices so different? Within particular income brackets, quintiles such as 0 to 400, 400 to 800, 800 to 1200, 1200 to 1600, 1600 to 2000 Egyptian pounds per month, we would see more similarities, or would we see more similarities between these two communities? And if not, why not? As I began my research, I found that the GTZ data was wrong. There was nobody who was without hot water. Everybody had some way of getting water heated for bathing and clothes washing. I also found that the assumption of the bourgeois about their poorer countrymen was also wrong. Almost everybody I visited and talked to said that hot water was important, or very important, and that they needed it. The question seemed to be more, how important is convenient hot water, and what does convenient mean? What are the trade-offs? While roughly 50% of Cairo's historic slum dwellers are taking advantage of the availability of well-marketed and reasonably inexpensive, in terms of purchase price, electric hot water heaters, the other half uses gas, and of these, the majority heat their water on the stove. 15 to 20% have gas heating appliances, but they must use the same gas tanks that are used for stove cooking because no natural gas pipelines have been put into this part of the city. While the same condition persists across the city of the dead and the informal community of the Zabalin, the garbage pickers, this community shows slightly less than 30% using electric heaters and only about 6% using gas appliance heaters. Additionally, in Darb al-Ahmar, 4 to 8% still use the dangerous kerosene-burning babur, while a similar percentage of Zabalin residents use the dangerous ground stove or hamel. Why are these two adjacent communities behaving so differently? And why, given that they universally have access to subsidized electricity, while using gas involves high transaction costs and uncertainties, and using baburs and hamels carry such high health and safety risks, why are they behaving differently than the energy literature would predict, given that they're purchasing other electric goods, refrigerators, television sets, satellite receivers, that cost much more than water heaters? I was and I am intrigued by household energy utility decisions that appear to depart from what would seem like the best strategy for maximizing overall economic utility, in terms of time and opportunity costs, as well as money. Why were the urban poor of Cairo making the decisions they were for heating water? And what could this tell us about modernization and the assumptions we make about where household decision-making is headed at a time of climate change, rising and uncertain energy prices, rampant indoor and outdoor air and water pollution, and scarcity? Ultimately, my questions led me home again, home to what I could do at home. Why was I making the decisions I was for heating water? And if I could find a way to eliminate fossil fuels and nuclear power from my own life, at least as concerned obtaining my own hot water and electricity at home, then and only then could I realistically begin the dialogue of how to help others, help us all, get out of hot water.